Hey guys, we're about to do a really awesome review on these Wack-A-Packs and teach you kind of how they work. But the first time we saw these Wack-A-Packs was on RainyDayDreamers. They did a really awesome and funny review. You can watch that here. And at the end they were wondering, why do these work? And is it safe to cut these open without having a nuclear explosion or something? It is safe to open them. So they were nice enough to ask us. So we did a Google Hangout and we talked about them, and you get to see them open them for the first time and see what's going on, and it's really funny and awesome. So go check that out here. So once you've watched both of these videos, go ahead and watch a more detailed explanation on how these work. Hey everyone, it's Presley at ActOutGames.com here, and today we're going to be talking about how these Wack-A-Packs work. Ow! That hurt. It flew. Let me go get it.
Alright, so I don't know, maybe you guys have seen these. We got a really cool question from RainyDayDreamers, who are some good friends of ours back in Austin. Yeah. I kind of miss Austin. Presley was born in Austin, in fact, before we went to Hawaii and then ended up here in Denver. But they found these little packs. One of their viewers, I think, recommended these to them. And and as you can see, when you smack them, the balloons fill up and they pop and they fly all over the place.
And then I scream.
And Presley screams, and they do cool stuff. And it was such a neat little thing. And so they knew that Presley and I, we like to do science videos. And so they asked us to figure out how it works. And we just actually did a Google Hangout with them today and talked in a little bit of detail about how they work. But we thought we'd do a more detailed video now and explain it even more. Yeah?
Yeah.
Cool. So let's talk about what's going on inside of one of these things.
Okay, so should I pop one to...
Well, no, why don't you just tell us a little bit about what's going on in there first, and then we'll cut one open and we'll show some things. And yeah, but let's talk about it.
Not to just go bang.
What's happening inside?
So what's happening inside of here is there is baking soda or baking powder. I'm not sure which one. They both work.
Yeah.
So
baking soda, I think.
Probably baking soda and a packet of citric acid mixed with water.
Yep.
So when you smash it, you break that bag, and the citric acid, the baking soda, the citric acid and water and the baking soda mixed together. And since baking soda is a carbonate, it produces carbon dioxide. But even if you're using a base that was not a carbonate, it would produce salt and water. It produces salt, water, and carbon dioxide, which fills up the balloon because it's using a carbonate.
Yep.
But if it wasn't using a carbonate, like if you're making an acid and base that doesn't have and without a carbonate, then it would produce just salt and water.
Yeah, and the balloon wouldn't blow up.
Yeah, and the balloon wouldn't blow up.
Yeah,
it would if they were just put in an acid and a base, you would just punch it, and you would have a balloon with some water and salt in it.
So you would have salt water in it, right? So yeah, it's a basic chemical reaction that's an acid and a base. And what do you call it when you mix an acid and a base together?
Neutralization.
Neutralization. They neutralize each other. So the acid's no longer really an acid, and the base is no longer really a base. It becomes a neutral substance, right? What makes an acid an acid?
It has a lot of hydrogen ions in it.
What's another name for a hydrogen ion?
A proton.
A proton. It's just a proton, right? And so that proton wants some electrons, right? And so that's the way an acid does damage to things is that it steals electrons. Yeah, it just grabs a bunch of electrons, right? And then what's a base?
And a base is something that has some extra electrons.
Yeah, so it wants to give up some electrons, right? So when you mix them together, the base gives up some electrons, the acid takes some electrons, and everybody's happy. They've all got what they want, right? And so an acid and a base, and they make a salt is what they make. And a little bit later we'll draw on the whiteboard a little bit and show how exactly chemically they make salt. I thought maybe we would start sort of as simple as possible and then work up to a little bit more complicated with the science. But in the end, we'll draw on the whiteboard and show some of the chemical formulas for how some of these things happen, right?
So it's kind of cool how, like I said, you pop the bag and then the chemical reaction happens. This cool thing is it's just popping a bag.
Just popping a bag.
Just punch it and you pop a bag.
Yeah, let's cut one open and look and see what's inside.
Okay.
You want to do it?
Sure.
Okay. So we'll take out one of the balloons and let's look and see what's going on in there.
It's so hard not to pop this. Oh my god. Just like...
Be real careful.
I know.
Okay.
My life. These things are my life. I want to get like the 20 billion of them.
So I definitely think you should give them out in school. All right, so here's the balloon, and this was inside of this little pack. That's what pops, right? And you can feel the little thing in there. So here, let's go ahead and cut.
You go ahead and
cut the balloon open.
Don't make baking soda fall everywhere.
And then what is this experiment a lot like, Presley?
The volcano that most of you have probably done, where you take baking soda and vinegar and you dump it together and it goes whoosh.
That's exactly right. Which one is the acid?
The easy vinegar.
Vinegar is an acid, and vinegar is an acid that's in water. You know, like when you buy vinegar, you get it, it's in water already.
Yes.
And then the baking soda, what's baking soda?
It is a carbonate.
It's a carbonate. So when you mix them together, what do you get? What three things does it make?
It makes salt, water, and carbon dioxide.
That's exactly right. That's all there is to it.
Except I haven't really experimented with the whole salt thing with volcanoes.
Yeah, well, there's salt in there. You just don't really know it. All right, so let's shake this thing off a little bit. So here is the little packet. What's in that packet?
This packet is filled with citric acid.
And
water.
Water. Yeah, distilled water and citric acid.
Most of these packets that I've taken out have these weird white crystally things. Do you know what those are?
Citric acid.
Citric acid.
Yeah. So that's the citric acid that they put in and mix with the distilled water. Yeah. So the liquid's distilled water and it's sort of dissolving in there.
Oh.
And
so
in a little bit.
Citric acid is a powder.
Yeah. In a little bit, we'll talk about why it has to be in water. That gets a little bit more sciencey, but first let's just talk about this piece. So what we'll do, I think we'll show you, and we did this with Rainy Day Dreamers today, but we'll show you what happens when you do, what's going on inside the balloon when you pop the bag. So I'll dump the baking soda into this little test tube.
Well, we're not sure it's baking soda, but it's some sort of carbonate.
And this is one of our cool, oops, I missed a little bit. This is one of our cool Steve Spangler test tubes. What are these, Presley?
These are soda bottles. I was going to put that in there.
These are, yeah, they're 2-liter soda bottles before they're sort of blown up. They're stopped, halted in the middle of the manufacturing process, and they make just phenomenal test tubes.
Yes,
so I'm going to get this baking soda in here.
I think.
Okay, so now we have the baking soda. That's the inside of the balloon.
And now we have the citric acid.
That's right, and so Presley is going to put the citric acid in here.
So we're going to put the citric acid above the thing.
I'll hold it, you cut it.
Okay, you hold it just above the thing. And I will go. It's already starting to fizz.
Fizz. And what's the fizz, Preachon?
And the fizz is the carbon dioxide.
Carbon dioxide gas. That's all there is to it, right? So mixing those two things together makes carbon dioxide, and that's what fills up the little mylar balloon that's inside.
We can do one of those ourselves.
And that's really all there is to it. So that little packet that you saw, got another one right here.
Yes.
Little packet that you saw that's inside. When you hit it, all you're doing is busting that balloon.
Yeah, we're popping
and then that lets it mix because that baking soda is just loose inside the balloon, and that's all there is to it. And we thought we'd show you too. We did this on the other one too. So this is vinegar, and that's a little bit stronger acid. So Presley's going to put some baking soda in this tube with the vinegar, and you can watch what happens. Just dump it in all real quick.
Whoa!
So a little bit more violent reaction. Same thing.
More violent than last time.
It makes more carbon dioxide gas, and that makes bubbles, and we have paper towels so that we can deal with this when it happens.
So we don't have a table that is forever stained with this.
So you're getting exactly the same thing that's happening, right? You're getting a carbonate mixing with an acid and making salt, water, and carbon dioxide. So let's show one more cool thing before we dig into some of the detailed science a little bit and kind of show how this works.
Replica?
Yeah, we're gonna do a replica.
Okay, yes. So our replica. Well, I can explain how we make the replica by myself.
Yep.
So basically, this is just some
saran wrap.
Saran wrap. I was gonna say tinfoil. This is not tinfoil. Some saran wrap, and we put saran wrap on a little glass bowl.
Yep.
And put vinegar in it, and then just wrapped it up into this little packet.
Yeah, and we'll show some footage here of us doing that so you can see.
Yep.
So yeah, just
and then we put it in a balloon.
And then you just take the saran wrap and tie a knot in it so that you've got a little packet that's almost exactly like what you saw in that balloon. And so that's just vinegar in there. And then we've got these balloons. I'm going to open the balloon up, and Presley's going to drop that in. Put them up there. Okay, go in. Okay, cool. So we got that.
And then you add some of this.
And then you're going to drop in
like 2 spoonfuls or 1?
Teaspoon of baking soda.
Like this?
Yeah, drop it in.
Boop, like a Cooper spoon.
Okay, drop that in.
Boop, drop it.
And then you can tie your balloon off, just like you would normally if you had blown it up. And you've got a replica of what those little things are. So we'll put that down and let Presley smack it, and we'll see if it fills up.
Let's see. So let me find out where the saran wrap thing is. Okay, that's a knot, I think. So.
Yep, I hear it. So shake it up a little bit and get it to mix, and you can start to see
it's growing.
The balloon starts to grow. And it doesn't grow as fast because one thing you've got is that these, you've got the elastic of this balloon, so it has to push on the outside of the balloon, whereas these are just little mylar that it just fills up with air, right? So it doesn't have to generate as much pressure as it does to blow up this balloon. But yeah, you can make your exact copy of what's happening inside of these balloons. The other thing that you'll notice when you do one of these, like if you blow one of these up or if you make your own, is that, what does it feel like?
It's cold. Oh God, it is colder than I remember.
It's very cold. Why is it cold?
And it's cold because this is an endothermic reaction.
It is an endothermic
which means
reaction.
it absorbs heat.
Right.
So it's absorbing all the heat from out here, making it colder. Oh, that's cool. If you squish it, ooh,
Changes the shape.
it can change the shape. That's
Right.
interesting.
Yeah, so it takes heat for the chemical reaction that's taking place to happen. And so while that chemical reaction is taking place, it's absorbing heat from the surrounding area. And if you take heat away from something, what's left?
It's, well, cold.
It cools. Yeah, it makes it cold. So the stuff around it is cold while it's absorbing all of that heat to make the chemical reaction happen. So it's called what again?
An endothermic.
Endothermic reaction. And what's the opposite?
Exothermic, which means it releases heat.
Yeah, an exothermic reaction, releases heat and makes it
Play
hot.
with this. It's fun to squish balloons.
So, right.
Squish balloon.
So the that's really all that's happening inside. I mean, it's so simple for such a cool and like clever little packet, and a fun thing to do. And I think Presley will probably take a ton of these to school with her for the Valentine's celebration book and give them to her friends because it's so cool. So let's. I think we're going to go to the whiteboard and draw just a little bit of the chemical reaction that's taking place, so people who care about what's going on can see it. Before we go up and talk about it, let's talk about why it's important that it's in water real quick.
Okay, it's important that the reaction takes place in water because both the acid and the base are ionic.
What does that mean?
And it means it has a charge. So one end has a negative charge and one end has a positive charge. So
Well, there's two molecules, right?
Yeah.
It's a compound. It's an ionic compound. So there are two things. One of them is positive and one of them is negative. And so they stick together. That's an ionic bond.
And one of these has to be a hydrogen ion.
Yeah, for the acid, one of them is a hydrogen ion. So when you put them in water, what does water do?
It is really good at breaking those.
Yes, it's excellent at breaking apart ionic bonds.
Which is one of the things that is cool about water, as water is amazing, but
One of the many things that's very cool.
thing that's very cool
Yeah.
about water is it's so good at breaking apart ions.
That's why it's called the universal solvent.
It's just
because
like
it breaks those things
karate
apart.
chop.
Yeah, so it breaks them apart, and one of those things is hydrogen ions. And like I said, that's what sort of defines an acid, is that it has a bunch of hydrogen
And
ions.
then the
flying
hydrogen
around in it.
ions are all floating around in the water, and
Yep.
then something else is all floating around in the water, and they're not sticking together.
Yeah, and so the other thing, the base is the same thing. It's an ionic compound, and one of the halves is a hydroxide. And so it breaks apart, and so you have a bunch of hydrogen ions, and you have a bunch of hydroxides, which are OHs, and then they join back together, and you have two hydrogens and an oxygen, which makes what?
And two hydrogens and an oxygen, which makes water.
Water,
H2O.
Two hydrogens and an oxygen, H2O. So those things form back together and they make water. And then the other two pieces, whatever they were, they join back together, or they join together.
And that makes a salt.
And that makes a salt, and that's pretty much what a salt is. And so we'll get up on the whiteboard and we'll draw one of the more common reactions that actually makes table salt in water. And we'll take a look at how that works. Cool. So these are really awesome, though. These are definitely get them at the dollar store. It's 4 for $1, I think, in a little pack, and they're super, super, super cool, and the kids will love them. And you get to talk about how they work and have a little quick science lesson, which is we always love. Right?
Right.
All right, let's go upstairs. We're going to talk about one of the most famous, or most, the coolest to me, acid-base reactions. Okay. So the acid we're going to start with is hydrochloric acid.
Which is stomach acid.
It's what's in your stomach. But it's a lot
So
of
don't try this at home because that's stomach acid. You don't want that.
It's a lot of acid. It's a strong acid, right? And so it's an ionic compound, like we talked about. So the hydrogen is positive because it has lost its electron, and the chlorine is negative that's in there, right? And so it mixes with sodium and the OH, the hydroxide group that we talked about before. So all the bases have this as part of their ionic compound, and all of the acids have this as part of their ionic compounds.
So this is going around.
That's right.
And this.
That's exactly right. So this is what makes an acid, is that it's an ionic compound that has this H plus, and it is a base if it has the hydroxide group, right? And these are really twos, but that's okay. Don't worry about it.
Yeah.
They've got a positive charge and negative charge. And so what happens when you put these in water?
When you put these in water, they break apart.
Yeah, it breaks apart those ionic bonds. So you end up with a hydrogen that's positively charged. You end up with a sodium that's positively charged. You end up with a hydroxide group that is positively charged.
That's negatively charged.
Or negatively charged, sorry. And you end up with a chloride that's negatively charged. And then these things are floating around, and the stronger attractions pull these together and pull these together.
And
so
what these are?
Yep.
So this OH is an oxygen and a hydrogen plus a hydrogen. Guess what that makes? Have you guessed? It makes H2O.
Yep, that's right. two hydrogens and an oxygen come together, and what is that?
Water.
Water. And then on the other side,
turn into Na, which is
sodium chloride.
Which is salt.
Which is salt, table salt. So you take this really nasty acid and you mix it together with a base, and you get
salt and water.
Salt water, right? It's very, very cool that that happens. And the same thing kind of happens like in chemistry when you're dealing with like this chlorine is really nasty stuff. They use it in poisonous gases.
They use it in cold water.
They use it in all kinds of stuff, and it's really nasty. You wouldn't want to drink this, right, or eat it. But if you mix it together with a little sodium, suddenly you get salt, and we put it on all of our food, and it's totally perfectly safe to eat, right? So chemistry, the way things change when they join together in combination is a big part of what chemistry is, right? But when you're dealing with any acid is going to have, you know, an H plus something minus, and then any base is going to have an OH minus, and then a something plus. And then depending on these two things, like these will join together when you put them in water, and that'll make water. And then these two things will join together.
Depends on which salt it's going to make.
Yeah, so depending on which two things you have mixed here determines what salt you're going to make. And a salt is when you mix an acid and a base together, these two things join together and they form a salt. And sometimes it's just regular table salt.
Yep. Which is pretty amazing how really nasty acid plus base equals thing that we put on our food every day and it's delicious.
That's exactly right. Yeah, that's how it works. Okay, cool. So that's like a much more detailed look at what's happening. So you can see how the things break apart and then they join back together in different pairs, and those pairs make what?
They make water and salt.
Water and salt. That's exactly
right. Occasionally carbon dioxide.
If it's if the base is a
carbonate.
If the base is a carbonate, you get carbon dioxide. So yeah, I hope you guys learned something in here, and you get these things, cut them apart, play with them, make your own version of it. You know, mix them up in little test tubes or whatever, and watch and see what happens, and you'll understand a ton about acid and base reactions, right?
Yep.
Cool. Awesome.
So yeah, thank you for watching, and we'll see you tomorrow. Bye.
Bye, guys.
It's time to press the subscribe button. Subscribe button. Subscribe button. Subscribe. Bye 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 bye.